Imagine being able to access high-speed internet from virtually anywhere on Earth, even the most remote locations where traditional internet infrastructure is non-existent. This is the promise of Starlink, a satellite internet constellation developed by SpaceX. Starlink represents a fundamental shift in how we connect to the internet. Unlike conventional satellite internet that relies on a few large satellites in geostationary orbit, Starlink uses thousands of small satellites in low Earth orbit, or LEO. These satellites orbit much closer to Earth, between 340 and 550 kilometers above the surface. The key to Starlink's effectiveness lies in its constellation approach. By deploying thousands of satellites, SpaceX creates a mesh network in space. As of now, there are over 4,000 operational Starlink satellites, with plans to eventually launch up to 42,000. This massive number ensures consistent coverage across the globe. Each Starlink satellite weighs about 260 kilograms and is roughly the size of a table. They're equipped with ion thrusters powered by krypton gas, allowing them to maintain their orbit and maneuver to avoid collisions with space debris. The satellites also feature 4 powerful phased array antennas that create focused beams of signal. The orbital pattern of these satellites is carefully designed. They travel in shells at different altitudes and inclinations, creating a web that provides continuous coverage. As one satellite moves out of range, another comes into view, ensuring uninterrupted service. The satellites communicate with each other using laser links, creating a space-based data highway. On the ground, users connect to the Starlink network using a specialized terminal often called a Starlink dish, or Dishy McFlatface, as SpaceX whimsically named it. This dish is actually a sophisticated phased array antenna that can electronically steer its beam to track satellites as they move across the sky. The terminal requires a clear view of the sky to function properly. When a user wants to access the internet, their data request travels from their device to the Starlink terminal. The terminal beams this request to a Starlink satellite overhead. The satellite then has 2 options. It can either relay the data through laser links to other satellites until it reaches one above a ground station, or it can directly transmit the data to a ground station within its range. Ground stations are essential components of the Starlink network. These facilities are connected to the traditional internet backbone and serve as gateways between the Starlink constellation and the broader internet. When a satellite receives data from a user terminal, it routes that data to a ground station, which then connects to the internet servers hosting the requested content. The response follows the same path in reverse, from internet servers to ground station, up to a satellite, possibly across multiple satellites via laser links, and finally down to the user's terminal and device. This entire journey happens in milliseconds. What makes Starlink revolutionary is its low latency compared to traditional satellite internet. Because the satellites orbit much closer to Earth, the signal has a shorter distance to travel. Traditional geostationary satellites orbit at 36,000 kilometers, creating noticeable delays. Starlink's low Earth orbit reduces this latency to levels comparable to land-based broadband. The system operates on the Ku and Ka radio bands, with frequencies ranging from 10 to 30 gigahertz. These high frequencies allow for greater data capacity, but can be affected by atmospheric conditions like heavy rain or snow, a phenomenon known as rain fade. Starlink's coverage continues to expand as more satellites are launched. The service initially focused on higher latitudes, but is progressively extending toward the equator. In areas with complete coverage, users can expect download speeds between 100 and 200 megabits per second, with latency as low as 20 milliseconds. The technology behind Starlink represents a significant engineering achievement. Each satellite must precisely maintain its position, track moving targets on Earth, manage power from solar arrays, and coordinate with other satellites in the constellation. The ground terminals perform equally impressive feats, automatically setting up and tracking satellites without user intervention. Starlink is transforming internet access for remote areas, rural communities, and developing regions where traditional infrastructure is impractical or too expensive to deploy. It's also providing connectivity in disaster zones and offering a new option for maritime and aviation internet services. As the constellation grows and technology improves, Starlink continues to evolve. SpaceX regularly launches improved satellite versions with enhanced capabilities. The ultimate goal is to create a truly global network that connects the unconnected and provides a competitive alternative even in areas with existing internet infrastructure. This space-based internet system represents a convergence of advanced technologies in aerospace, telecommunications, and computing, all working together to solve one of the modern world's fundamental challenges: universal access to information.